the top of the hour on my clock, so we're going to get started so we have enough time today. Welcome, everyone. I hope everyone's doing well. I'd like to thank you for taking the time out of your day to come join me on this webinar where we're going to talk about repairing and reducing slope erosion using the GeoWeb 3D soil confinement system. So we're going to be talking about the GeoWeb GeoCell system, what it is, if you don't know, and how you can use the slope protection system to reduce surface erosion on all kinds of slope faces. I'm your host, Sam Justice, and I'm a licensed professional engineer in Wisconsin and Kentucky with degrees in civil and geotechnical engineering. I'm one of the engineers here at Presto Geosystems, and we manufacture erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States. Through an extensive national and international distribution network, we offer technical and site support, as well as free project evaluation from our in-house design engineering team, like me. So here are a couple things that I hope you get out of today's webinar. Understand the causes of surface erosion, pretty high level, we're not going into great detail there, but we're going to learn about the GeoWeb system, how flexible and versatile it is, and know that the system can work on even very steep slopes. And just so everybody is aware, this presentation is going to be about slope surface erosion only. We're not going to be talking about the global stability of slopes today. We do have solutions for retaining wall needs, but you're going to need to reach out directly for those questions today or go into our library of other webinars to get that kind of information. So first, a little bit of background on Presto Geosystems. We worked with the U.S. Army Corps of Engineers to develop the GeoCell technology in the late 1970s and have been innovating in this market ever since. Our products have been used in over 200 countries and in every state in the United States. We go beyond simply providing a product. We're here to help you provide a complete stabilization solution. So we do operate in three main product areas: soil stabilization using our GeoWeb GeoCells, which can be used for load support, slope and channel protection, and constructing green retaining walls. And then also we work in porous pavements, of which we have both a vegetated and aggregate solution, and lightweight reusable construction mats. So today we are going to be focusing on that top line using GeoWeb GeoCells, specifically for slope protection. So we're going to start with a really quick overview of the broad classes of slope failure due to erosion that might be a solution for the GeoWeb system. So the big obvious slope failures, the ones that everybody sees and points out, are almost always global failures with large mass movements. So as I said, we're not really going to be focusing on this type of failure and remediation today, so we're just going to move on. But I do want to point out it is something that we're aware of. We have those solutions in the retaining wall type of remediation, just not going to be talking about it today. So surface erosion is going to be the name of the game today. The main cause of surface erosion is obviously water flow, whether it's from the crest of the slope causing rills and gullies to form, or maybe it's coming through the middle of the slope due to an action such as piping. Dams and embankments holding back water are really susceptible to piping. And while the GeoWeb system can help with erosion once that piping has happened, it's not going to fix the cause of piping. So just something to keep in mind. So again, we're really just focusing on the actual surface of the slope. Things like shoreline erosion due to rivers, ponds, lakes, even ocean coastlines, where you have currents or wave actions that are going to attack that underlying soil, that can be something that can be solved with the GeoWeb system as well. And finally, while not really considered erosion, misapplication of erosion control blankets or turf reinforcement mats can lead to slope surface failures and require installation of a more stable slope protection system. This is where the GeoWeb system could come in. Okay, so with all of that sort of refreshed in our minds, we're going to now cover some general information about the GeoWeb GeoCells for those who might not be familiar with this type of product. So the GeoWeb system is our version of the GeoCell technology, and it consists of two main attributes. The first is going to be the cell or the container size. The cells come in three diameters, small, medium, and large openings, with cell heights between 3 and 12 inches. So these dimensions are going to depend on your project specific details, what your slope height is, what your angle is, that sort of thing. And we can help you determine which one is going to be the most appropriate for your specific job. Then there are also 5 section lengths to best fit your project needs. So there's a lot of flexibility in choosing the right GeoWeb panel for your project. Something I want to point out is going to be the ultrasonically welded seam. And that's where all of the connecting points are. It's going to be very important to the function of a geocell. The stronger that seam strength, the better the performance that the geocell will have. A strong seam allows for heavier infill material, steeper and taller slopes, and better overall lifetime performance. The GeoWeb system is produced using high-quality virgin high-density polyethylene, HDPE resin, for consistently strong welds at the cell junctions, while also maintaining semi-rigid ductile properties within the cell walls and having high stress crack resistance and overall toughness and long-term durability in the environment. So our geocells don't use any fillers or exotic polymer alloy blends that can also ultimately reduce that weld strength and the environmental stress crack resistance. Those sorts of things are offered in some competing products in the name of increasing cell wall stiffness, but to avoid weld failures and the damaging effects of differential settlement, you really want to focus on uniformity in performance across all of the elements of a geocell system. And that's going to be much more important than focusing on a single attribute such as wall stiffness alone. So the second main attribute of the GeoWeb geocell system is going to be the infill material. So that's going to be what you put into those containers. An important benefit of the GeoWeb system is that even a low quality aggregate, a sand, or sometimes even salvaged materials from on-site can be used as your infill material. Using salvaged aggregate or sands can save significant amount of money on material and hauling costs. You could also potentially eliminate the fines within your material as desired because the cells provide the confinement and aid in compaction of those cohesionless materials. Without the fines content, you can significantly improve the drainage and let the water flow freely through the system, preventing pore pressure buildup and global failure of your cross-section. The ability to use those granular sands and low-quality aggregates really sets the 3D GeoWeb system apart from things such as planar geogrids or geotextiles. Those products require very high-quality materials with very high friction angle materials to achieve their optimal performance. With the GeoWeb system, low friction angle materials are just fine. The GeoWeb panels will still achieve their full potential even with those poor quality materials, which can give you a really huge cost savings. So in order for the GeoWeb system to perform uniformly, it is critical that both the factory welded junctions, so those internal junction points, and the field join junctions that connect the individual panels, which are going to be your mechanical junctions, perform at a level that's commensurate with the cell walls. So the 3 primary elements of any geocell system, the cell walls, the internal junctions, and the connecting points, must perform uniformly as a complete system. Therefore, an incremental improvement in one characteristic, such as the cell wall stiffness, is only going to be valuable if a complementary improvement has been made in all of the other components of the system. The GeoWeb system is manufactured using a proprietary blend of high-quality virgin HDPE resin. Our proprietary formula has stood the test of time for more than 40 years and contains no fillers, no unstable polymer combinations, no exotic polymer alloy blends. And for most typical sites, the GeoWeb system is going to retain its durability for more than 50 years, with lab testing indicating 149 years without degradation, even at full exposure to the elements. We stand behind our numbers so that you can deliver certainty in a solution as you build with materials that you can trust. Something that we've seen a lot of recently, and perhaps you've heard of it in the news, is microplastics. So basically leaching of plastic materials into our drinking water system, into our food-based system, basically things you don't want. But because we are made with high a high stability inert material, that HDPE, GeoWeb's geocells are going to be your permanent stabilization solution and are not going to degrade, leach, or release any type of microplastic into your environment. The GeoWeb is manufactured with no fillers, polymer blends, competitive stabilizers, all those things I've mentioned a couple times. Our base resin is the same material that's used in environmental applications, things like geomembrane liners and other environmental barriers that are already common on the market. And it's to protect against the spread of harmful toxins. Our products have been tested by third-party applications by accredited geosynthetic laboratories, confirming long-term stability against environmental factors such as weathering and oxidation. Like I said, the GeoWeb panels are predicted to be durable for more than 100 years in your natural soil based on analyses. And when subjected to UV radiation, so when exposed to sunlight, and even accelerated weathering conditions, specimens retain 100% of their original tensile strength with no loss in mass or change in visual appearance. So we can say with confidence, you're not going to be leaching any harmful chemicals into a drinking water system. You're not going to be releasing microplastics into your environment. These are safe for use for much longer than any project lifetime. So you don't really need to worry about those potential environmental holdups that you may see with other types of plastic in your environment. And the GeoWeb and all of our accessories are 100% made in the USA under strict quality assurance and environmental control processes. So especially if you are in the United States and are perhaps working with federal dollars and you need to follow Made in the USA or Buy America regulations, all of our products do meet those standards and are acceptable for federal projects. So just a little benefit for the people in the United States. Okay, so system components. System components are going to be all of the supporting pieces that help the GeoWeb's panels protect the slope from those erosive forces, your water, wind, potentially if you're driving over your slope, anything like that. They ensure a uniform performance of the interconnected system across your entire project area. So I have a simplified diagram here to show how all of the different system components interact with the GeoWeb panels to form a complete system. We're going to talk about all of these components next, so don't worry if you don't fully understand what they are. So to begin with, you have your slope, some pretty standard dimensions. You got your slope angle, slope length, vertical height. So the first thing that may be placed is going to be a planar geosynthetic layer, such as a geomembrane liner. This is going to be entirely project dependent. It may not be there at all, but if it's necessary, this is where it goes. Then you put the GeoWeb panels in place. Note how the GeoWeb panels have that horizontal turn near the top of the slope. This is going to be important for crest anchorage and erosion control. We have two different options for anchoring. One is going to be using stake anchors. This would be placed along the slope face. These would be, like I said, mid-slope and at the crest. And then the number and spacing of those stakes is going to be project dependent. There is no one right answer. The other option for anchorage is to use tendons and some sort of crest anchorage, such as a buried pipe deadman, earth anchors, concrete anchors into existing infrastructure, that sort of thing. And then you fill in the GeoWeb with your desired infill material. If you are going to look for a vegetated solution, so you want some sort of grass or flowering vegetation to grow, we do recommend a biodegradable erosion control blanket be used until that vegetation is established. Okay, so if we think back a couple slides, the GeoWeb panels do come in discrete sections. So they have an average size of around 250 square feet. So your project is most likely going to be bigger than that. And so you're going to need multiple panels. The ATRA key is going to be the first component for that completely integrated system, connecting each individual panel of the GeoWeb into a single web that covers your entire project site. It allows for faster installation of the GeoWeb panels and is going to last the lifetime of the project, ensuring that the slope is protected and that the GeoWeb system isn't going to fail under anticipated loads. And the specific engineering values of the ATRA key will ensure that the system holds up to loading over time, without the corrosion seen in staples or the failure that you could see with underperforming cable tie systems. And our specification sheets call out the specific engineering values of this patented connector. So next we take a closer look at those anchorage options. Remember I said there were two. So the first one is going to be with stakes. So if the GeoWeb panels are laid completely flat, you really actually don't need anchorage because gravity is going to do all the work. However, if you're on a slope, which is what we're talking about today, you are going to need some sort of anchorage system. For shallow slopes, so think 2 horizontal to 1 vertical, about 26 degrees or shallower, stake anchorage is usually going to be sufficient. We have the two options for stakes. One is made of your standard steel rebar, and the other is made of high-density polyethylene, HDPE, same as the GeoWeb panels. So if you're in a saline environment, maybe you're along a coastline, or if you're in a highly acidic soil, maybe you're in a remediation site, the HDPE speed stake is going to be a lifesaver compared to the corrosion-prone steel stakes. And you can either drive the stakes by hand or by power drill, depending on your project. So for steeper slopes, a lot of slopes are going to be steeper than a 2-to-1. Or if you have a native soil that's really erodible, you've got maybe a really weak shale slope, or potentially even over a surface that can't be punctured. Maybe you have a geomembrane liner down that you don't want to puncture with stakes. The tendon anchorage system is going to be used. So our ATRA tendon clips transfer the load of the heavy infill material to the tendons and then up to a crest anchorage system. We talked about that a little bit earlier on that diagram. So the ATRA tendon clip is specifically designed to fully transfer safely and securely the forces placed on a geocell. Every accessory and every feature that we have has been designed and tested specifically to work together so that we can go from problem to design to construction solution with a system where the modeling replicates real-world forces so that you know that it's actually going to work and we're not just hoping it does. So the GeoWeb panels essentially prevent significant movement of that soil by confining the soil into those individual cells. So by separating the soil into those smaller segments, the system resists mobilization of the entire slope face due to hydraulic loads, so water flowing over the top, and prevents that soil erosion. You're not going to get that mass movement because the soil is confined into smaller pieces. So this is pretty much how it works. It's really simple if you think about it. And so it is important to reiterate that the proper installation of the GeoWeb system includes embedding the GeoWeb into the crest of the slope. This prevents water from flowing beneath the GeoWeb panels and undermining the system. You don't want rills or gullies forming underneath the panels where you can't see, because that could still potentially lead to failure. And the system provides a way to fully vegetate slope surfaces that otherwise couldn't support sustainable plant life, and increases the overall slope stability by interlocking with the vegetated root zone. Stone and concrete materials can also be confined within the GeoWeb panels, again on slopes that would normally be too steep to allow for a natural stone slope. But vegetated slopes are going to be the most popular option for protection because they can result in the most attractive slopes with little to no maintenance. Permeable slopes can be installed where high rainfall is anticipated or where construction projects are located in arid locations. If vegetation is just not going to grow there, use stone. And this approach can aid in the design of the project by limiting the runoff from those slopes and allowing the water to permeate into the underlying soil. You can also have hard armor slopes with concrete where they can be beneficial where there's really high water flows anticipated, such as along dam spillways or channel walls. And so this is a non-exhaustive list of some typical project applications we see using the GeoWeb slope protection system. As I said, not covering every potential option by any means, but it does give a good idea of the range of applications that the GeoWeb system can and has been used for. So pretty much if you have a project that needs to have this type of protection, we're good to cover it. We're not limited because of different types of applications. So we're going to start with some case studies. Everybody likes to see these sorts of things in action. So our first application type is actually going to be with vegetated slopes. You're going to get that vegetation, like I said, most popular option because it does result in that nice attractive vegetated slope. So this was a vegetated slope over an unstable soil slope at an active gold mine in northern Canada with variable slope lengths and face angles. An access road was also going to be built above the slope where that excavator is currently shown. So the slope had to be stable enough to support the expected road traffic live load as well. And here you can see some of the space constraints at the toe of the slope in the form of that access road and infrastructure already existing at the bottom. So a nice feature of the GeoWeb slope system is shown in this sort of after photo there, where the guardrail is installed at the crest and then there's a fence installed at the toe. So there's no limit to this sort of infrastructure being installed near or even on the GeoWeb panels. So it's a great benefit if you have tight spaces like this one. You can integrate it directly with existing infrastructure and include new infrastructure as well. So this project was along a road in Ohio, and it shows a common problem that's solved with the GeoWeb system: erosion and washout of soil from slopes onto road surfaces. Covering the slope with the GeoWeb system and then filling it in with topsoil allows for a vegetated slope without the concern of constantly having to replace that soil after storm events. We recommend some sort of surface protection, such as hydro seeding or biodegradable erosion control blankets, and those can be used over the filled GeoWeb panels until that vegetation has a chance to grow. So you basically fill in with the soil, throw some hydro seed over the top of it, let that grass grow, and now you don't need to worry about it constantly flowing onto your road and needing cleanup. Embankments along roadways have to deal with a lot of sheet flow runoff from that impervious surface, like this slope here, which was for the Maryland State Highway Administration. The sheet flow can cause some sloughing of large sections of that upper topsoil layer, causing deep rills or gullies, and essentially preventing vegetation from taking hold, even if it could have normally grown on the slope face. Because there's a lot of that water flow going over the top, it just keeps ripping up those new pieces of grass and not really letting it take hold. So the GeoWeb system is going to hold that soil in place while still allowing for the water to run over the surface. So no more gullies or rills, and vegetation can take its time to form those deep roots to further stabilize the soil. Things like road widening is also becoming a lot more common, with DOTs trying to find more roadway space without displacing any significant structures. Slopes and embankments are usually where that additional space is going to be found, as shown with this road widening project in New Hampshire. The GeoWeb slope protection system allows for steeper slopes to be created without erosion concerns. And the system can be installed quickly and vegetated quickly, so there's not going to be a long construction time that may shut down your important roadways. Ease and speed of construction are some important features of the GeoWeb system that everybody appreciates. So this is a really cool overhead shot of the GeoWeb system being installed on a slope face. You can see the variability of the slope in terms of overall height and slope angle. Plus, things like a large boulder are even left in place. You can see it sort of on the right side there, without causing significant interruption or disruption of the GeoWeb system. For this project, the tendon system was used, and those tendons were actually terminated with earth anchors along the crest edge. So you have those different options for how you're going to hold the GeoWeb system in place. And here's that finished product a couple months later. So you've got the grass fully coming in. And with the vegetation growth, this slope is going to last the full project lifetime. And you don't see the GeoWeb material anymore. So you're not seeing that black plastic on the slope. You are just seeing the nice vegetation growth. So don't worry if you're looking at it going, oh gosh, I don't want to see the plastic, it looks horrible. Let the grass grow in, get your vegetation established. You're not even going to know that the GeoWeb system is there. Okay, so our next case study actually shows the GeoWeb system along a shoreline embankment. This was for a large pond at the Chicago Botanical Gardens. So pretty high profile. People are walking by this area every day, and we needed to make sure that the pond was going to stay in place and not potentially undermine the pathways through the gardens. And so this was a vegetated system, and it was used to help stabilize that embankment. So you can see the crew is going with stakes in this case. You can actually see the guy on the far left is hammering in the stakes. They chose not to go with power hammer drills, and that's totally up to them. Small projects, maybe it's just not worth it. It's usually pretty easy to drive those stakes in. So in this case, they decided to de-water the pond, and so sheet piles were put in to allow for that dry construction environment. It's not actually necessary to de-water before installing the GeoWeb system. You can install during in wet environments. Obviously, it takes a little bit more planning that way. You're going to have some guys that are okay with getting wet, but it's definitely doable. So don't think that you need to fully de-water before installing the GeoWeb system. And the GeoWeb panels were filled in with native soil from the pond. So they were able to salvage the soil material. They didn't need to bring in anything new. And it allows for the same plants to grow over in this area. So you have that nice seamless look. And that's what you have here. Once the GeoWeb system is in place, those sheet piles were removed, the water was able to come back in, and now there's a thriving water garden in place with a much more attractive and stable shoreline. Requires very little maintenance. This is great for something like the Chicago Botanical Gardens, where they didn't want to have to come in and constantly be doing maintenance and take away from the natural beauty of the area. And so this project highlights a different issue that I haven't really talked about so far, but that's geomembrane liner protection. So this was a highway cut that actually exposed pyrite-bearing sandstone to the air and rain, and that creates the potential for acid rock damage. So definitely something that you want to avoid. So to remediate this, an impervious geomembrane liner was installed over the slope face so that air and water were not being constantly exposed to the slope face. But that liner needs to be protected so that it doesn't get punctured. If you puncture it, water's going to get through, totally defeats the purpose. So the GeoWeb system actually rests directly on top of the liner and is anchored with the tendon system so that you aren't puncturing through with stakes, you're laying it over the top of the liner, and it prevents damage to that liner over time. So this is a great way to cover things such as landfills, or if you need to protect drainage ponds that might have impervious liners to help stop chemical or waste leaching. So those are some options that you might have where you see a liner that you need to protect. And you can fill in with topsoil, you can fill in with stone, you can fill in with concrete. You're not limited in that aspect either. It's just how you want to see your liner protected. And the GeoWeb slope protection system can protect slopes at very steep angles if necessary. So this was kind of a unique project. It was along the Pan American Highway in Peru. And this is where the slope on each one of these terraces was about 1/4 to 1, which is going to be 75 degrees from horizontal. So definitely not natural slopes. I don't know of any material that can hold a 75-degree angle by itself. So these terraces were actually hand compacted to this angle. It was something that the local construction company decided was the best option, and actually was totally doable with the GeoWeb system. It does require a lot of anchorage to hold something at that angle, so something to keep in mind. But it is definitely doable, and you can combine it with other types of geosynthetics, such as biaxial geogrids that are embedded within the slope face to create that global stability, and then layering the GeoWeb system along the slope face for that surface erosion protection. And here's the final product. The vegetation was able to grow, was able to take hold. Those slopes are stable. It's definitely a very unique project. It's something that's very visually appealing, and it's going to be different than you see in a lot of places, and really only possible with the GeoWeb system. So this was a really fun application. Okay, so that's sort of the grand idea of vegetated slopes. But vegetation's not always possible or wanted, so you can go with aggregate or stone slopes. So aggregate infill can provide a low maintenance solution, great for areas where vegetation's not going to grow, where stone maybe is more common, it's just easier to get a hold of. And aggregate infill allows for that water infiltration, so it can be collected from road surfaces and it can be kept clean fairly easily. So this was kind of a fun project. It was a steep slope adjacent to a railroad track. Here, the natural vegetation of the slope was not enough to hold the slope in place after several record rainfall events had saturated the slope, brought all sorts of trees and debris down onto the railroad tracks, totally shutting them down. Obviously, the railroad company wanted this cleaned up and fixed as soon as possible. So once that existing vegetation was removed, the slope was regraded with a spider excavator, which I personally think is one of the cooler types of construction equipment I've ever seen. It's definitely not usual, but it's really cool, especially to see in action. But this allows for that slope to be regraded and make sure that it's going to be in good shape prior to the placement of the GeoWeb system. Because this was a newly graded slope, they chose to place a non-woven geotextile over the slope face prior to the installation of the GeoWeb system. And this is also a benefit to the GeoWeb system because it helps keep the aggregate in place and prevents it from getting underneath the GeoWeb panels, which could potentially damage the system and cause lifting. So kind of a dual benefit there. So the GeoWeb panels do sort of expand like an accordion. So think of them stretching out. The tendons can be threaded through those unexpanded sections for easy installation and then secured to your crest anchorage. And a single worker can carry an unexpanded section of GeoWeb panels. So it's really best to get as much of that done before they're expanded. Just saves you time, makes installation a lot faster, a lot cleaner. So after the tendons are threaded through and then connected with the ATRA tendon clip load transfer devices, we talked about those earlier, the GeoWeb sections are then draped over the slope face and secured together with the ATRA key connection device. That's going to be your mechanical connection for each one of those individual panels. And then enough of the panels were pre-connected to reach the full length of the slope, so they only needed to be connected side by side. And again, we do recommend as much of that be done on the crest as possible, just to limit the amount of slope side work, especially when you are on tall or steep slopes and you're going to have some extra protections that are needed to keep your guys safe. So the side-by-side connections were made after all of the panels were laid on the slope. This connects all of those panels and creates that single web of slope protection system. For shallower slopes, a crewman could just walk on the slope to connect those sections, but in this case, a man lift was used for safety and efficiency. Then you're going to infill with your material. As I said, this project chose to use a stone infill material because they just didn't want to have to worry about potential vegetation fall like what happened earlier. And so Presto always recommends that the panels be filled from the top of the slope to the bottom, crest to toe. This ensures that there's not an undue amount of weight pulling at the bottom of the panels, which could potentially damage the system. And then also just something to note, you can place a load on the GeoWeb panels immediately after the cells are filled. So obviously this guy is walking on the cells, that's totally fine, but you can actually put heavier loads such as vehicles on there as well. This is something that's a bit more useful not on slopes and in load application devices, or application projects, excuse me. And we can talk about those in the questions section if you have them, but we also have lots of information on our website about that type of application. But it is just something to note that you can apply load directly on top of the GeoWeb panels and there's not going to be a concern. And then, so this was the final solution. So this was a permeable aggregate. It doesn't require any maintenance, and the railroad doesn't have to worry about vegetation falling on the tracks anymore. And it is perfectly all right for the GeoWeb cells to be visible. You can see the panels here. You can see a little bit of that plastic. It's not going to affect the system performance. So it's really just a visual thing. And so that permeable aggregate reduces the water runoff and it eliminates the potential for that fall in vegetation on the track. So definitely checks all of the boxes for this particular project. Other types of things, this one was for the Minnesota DOT. They used the GeoWeb system to help stabilize the surface around bridge abutments and then again along railroad tracks and crossings. And the flexible nature of the GeoWeb panels means that it can easily contour to the slope face and around obstacles such as piles and abutments. And with the system in place, that water erosion is prevented around those abutments, so you're not having to have constant maintenance to come back, make sure those abutments are still in place. The entire project, in this case, was a mixture of topsoil with vegetation and aggregate infill. They used the aggregate below the bridges where the vegetation would have been difficult to establish, and then topsoil where it was exposed to sunlight and they could potentially have vegetation growth. So they were able to sort of mix and match and get the exact right project or right solution for their project. And like I said, the versatility of the GeoWeb system allows for that variety of infill. You can mix and match. You aren't just limited to a single type of infill. You can use whatever best meets your project needs. In this case, this was actually a quarry abutting up against a roadway. So aggregate fill was used on most of the slope, but then they actually used concrete fill in the higher flow areas where they knew that they were going to have some heavy water flow over that area. They were able to use concrete there, but stone everywhere else, was able to save on material costs that way. And that brings us to our last type of application for slopes, and that's going to be concrete slopes. These are flexible, hard armor protection slopes. So like I said, concrete is going to be the last main infill type, and the system is no longer considered permeable at this point, but it is still considered flexible. It's called a hard armor solution. But there are going to be things like no maintenance requirements, and the embankments can handle significant amounts of stormwater runoff if needed. So the GeoWeb panels themselves act as the formwork for the concrete and as the internal reinforcement for the concrete. So you don't need to build up forms, and you don't need to include things such as steel rebar or fiber reinforcement within the concrete. The concrete itself is poured directly into the GeoWeb panels and then screeded to the top of the cell walls, so you're ensuring a consistent concrete depth without it slumping to the toe of the slope. And so concrete filled GeoWeb or hard armor slopes are best when there's going to be water flow. So this was a channel project that takes the water runoff from a train intermodal yard. The GeoWeb system replaced a design that had 6 inches of reinforced concrete channels with 4-inch deep grout bags on the slopes. The GeoWeb system was actually a value engineered a VE solution due to cost overruns. So that 6-inch reinforced concrete was able to be switched over to a GeoWeb reinforced concrete. And the GeoWeb system saved the owner a couple $1 million, and more importantly, sped up construction and allowed the yard to be in service significantly faster than originally planned. So definitely wins for your client. So the side slopes for this channel used 3-inch deep concrete, so they were able to go from 4-inch grout bags to 3-inch deep GeoWeb panels, anchored with stakes because those slopes were relatively short and shallow. And then the bottom of the channel used 4-inch GeoWeb, so going from 6-inch reinforced concrete to 4-inch GeoWeb concrete. And this allowed for it to support vehicle load, so it could still be used as an access road, great for maintenance. That's another way the flexibility and the versatility of the GeoWeb system can be used to create the right solution for your project requirements. Like I said, the GeoWeb panels themselves act as the form for the concrete, so there's no need to build one, which can be tricky on slopes, and in any event is always going to extend your construction time. So the concrete is poured from the top to the toe, so crest to toe, same as before, and then the cells hold that concrete in place and prevent it all from slumping and creating areas of uneven thickness. Speaking of thickness, an advantage of the GeoWeb system is that it ensures that consistent placement thickness across your entire project site. And as always with concrete projects, pore pressure buildup is going to be a concern. And so we do recommend having some way to relieve that pressure. In this case, they drilled weep holes through the set concrete to relieve that pressure. You can also pre-install weep holes before you pour the concrete, or you can have some sort of filter fabric underneath it if you know that you have very little groundwater movement. Definitely, it is project dependent what's going to be the right option, but definitely consider it. You don't want to forget about pore pressure and have some sort of underlying damage happen to the system. And then here we can see that full extent of the project. It was more than 1 million square feet of GeoWeb, and it saved the railroad a significant amount of time, money, installation time, all of those good things. So this was kind of a cool project, lots of different applications, and we're able to get things back in service a lot faster for the yard. So the GeoWeb 3D soil confinement system has great flexibility of design. You can choose from a variety of infill materials to meet your project needs. Steep slope protection is not out of the question when using the GeoWeb system, and know that it is a complete system solution for ease of installation and peace of mind. And every project is different, but Presto Geosystems has a solution that's going to be right for you. The GeoWeb system can be added to projects to provide a more stable, longer lasting, and flexible system. So you know that you're going to get something that's right for your specific project, not just a cookie cutter solution that may or may not meet all of your needs. And as part of our complete solution is going to be our technical assistance. So the engineering team, myself included, here at Presto Geosystems works closely with landscape designers, engineers, contractors, owners. We do offer a free project evaluation service for any type of slope, embankment, erosion control project that you need. The form is on our website at prestogeo.com. You fill it out with as much information as you have. You can include attaching documents such as geotechnical reports, project site photos, any other information you may have, and it comes directly to myself and the rest of the engineering team. And it is, again, at prestogeo.com, and then you can see along the black ribbon at the top, the very first one, free project evaluation. And so within 3 business days, but usually a lot faster than that, we provide that complete design evaluation. So we're going to give you the recommendation for the thickness of the GeoWeb panels, what type of anchorage requirements are going to be needed, whether you should include or have any sort of geotextile, geomembrane, any sort of geosynthetic underneath the GeoWeb system, all of that good stuff that you're going to need to be able to include the GeoWeb system in your project. And so we're going to work with you to get the best design for your needs. Again, not just a cookie cutter thing. This is going to be project dependent every single time. And like I said, we deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our specifications so you can deliver certainty and build with materials that you can trust. No disclaimers, no concerning fine print. We believe in our materials, and we hope that you do too. So obviously, one of the biggest questions you always have about these sorts of things, including a new type of geosynthetic on your project site, is going to be about cost. No surprise there. So especially if this is a new technology for you or your area, having an idea of how much the GeoWeb system costs compared to other stabilization techniques is going to be really important. It might even be the first step. So here we have a basic comparison for the GeoWeb system for a load support application. So this is a little different than what we've talked about, but the idea is still there. So this is still going to give you an idea that the different types of geosynthetics exist and that you have different options to choose from. So this comparison shows the difference in both price and cross-section depth using an unreinforced system, a GeoGrid reinforced system, and then using the GeoWeb system. And there's 2 different GeoWebs. One is using a engineered stone brought in from off-site, and the other is actually using on-site salvaged materials as your infill. So you 2 options with the GeoWeb system there. And so you can see the GeoWeb system is going to be both thinner and less expensive than the other methods. Significantly so when the on-site material is used. When you are able to reuse the material that potentially you've excavated, or if you know that you have a really local material site that you can access, you're going to save a lot of money that way. In fact, you have about a 40% savings, which can be realized compared to a GeoGrid and geotextile section, which does not allow for that use of on-site materials. So definitely something to consider. And of course, your aggregate costs and your distance to quarries may vary, so keep that in mind. But this is going to give you that general idea of the type of savings that can be achieved. It is both for cost, but it's also for depth. And a lot of times that can be just as important as the cost. So keep this in mind. We're always happy to talk about this more on a project dependent basis. Because it is so project dependent, there's not always a quick answer to how much does this cost, but we are definitely willing to walk through it with you. And that's my presentation. So thank you so much for attending. If you do have any questions, feel free to reach out to me directly. My info is on the screen right now, or we do have a info at box that you can reach through our website. So if you don't write my information down, but you can remember our website, you can contact us there as well. A little bit of housekeeping. You have earned a PDH credit for listening to me talk today. So I hope that makes it worth it. And so we do have something called a webinar dashboard. And so this is where you can easily view our library of webinars. We do have quite a library, little backlog of webinars that you can watch about other types of GeoWeb systems that you can use. And you can also then download PDH certificates for those webinars that you've watched, so you can get on-demand webinars and still earn those credits. And then the webinar dashboard is going to keep a record of those webinars that you completed so that you have that for your records as well. So in 2 to 3 days, so by the end of the week, you'll receive an email from Presto Geosystems with information about accessing that webinar dashboard, along with some other helpful resources based on what we talked about today. If you watched live, if you were here on Tuesday, July 25th, you will receive a PDH certificate from GoToWebinar. It should arrive to you in about 2 hours from now. So it's not coming from Presto Geosystems, it is coming from GoToWebinar, so maybe check your spam folder if you don't see it, but it is coming to you directly today, so keep an eye out for that. So thank you everybody for attending. There are a number of questions that I would love to answer, but if you need to hop off, definitely I understand that. The Q&A session is still being recorded and will be included in the webinar dashboard. So if you do have to get off, you can always get on the dashboard later and either re-listen to me or skip to the end and get to the Q&A session there. So let's see what some of the questions were that people had. A number of questions about the vegetation that you can use. So what type of vegetation do we recommend? Are there any limitations on size, type, etc.? So yeah, so basically vegetation is going to be kind of local to your area. You want something that you know is going to grow in your environment. So there is not, you know, one specific type of grass that we're going to recommend. I don't know if there is a specific type of grass that anybody would do. You obviously want it to be local to you. We do typically recommend things like grasses and small flowering vegetation, something that's going to have wide coverage with a lot of root zone, and that's going to give you the best stability of that topsoil within the system. It's going to be really interlocked and hold it all in place. But you know, a lot of times people do want to put in some larger vegetation, trees, shrubs, a lot more larger decorative vegetation, and that's definitely doable. You can, if it's a relatively small tree or shrub, you can place it directly within the GeoWeb cell. So you wouldn't need to cut or anything. You would just place it within that opening and then fill in with the soil around it and let it grow. If you do have a larger tree, if you want something pretty large to be able to grow, you are able to do a small cut through the GeoWeb panels to open up a larger section to allow for that root ball of a tree to go in. You obviously don't want to have too much of a cut. You don't want to create too big of an area because that sort of defeats the purpose of the GeoWeb system, but it is definitely doable. So if you have questions about that, if you want to know how many trees I can plant or how much of a cut I can do, feel free to reach out directly and we can talk about it on your specific project, but know that it is possible. Some other questions. So how, when you are using a soil or like a fine-grained material, perhaps you have a sandy soil that's going to have those smaller grains, how are you going to handle that with, you know, water flow over the top of it? And really the best option is to try and grow some sort of vegetation in those areas, even in the sandy soils, which obviously, obviously growing grass in sand is not the best, but we do try and recommend getting something in there to help hold those fine-grained materials in place. You can also put things such as turf reinforcement mats, so some sort of permanent surface on top of it, and that would hold that material within the GeoWeb cells as well. So you definitely are able to use finer grain materials. You just have to be aware that until you either get that vegetation established, or if you need to put something over the top of it, there's the potential for minor amounts of washout of that fine grain material. So let's see some questions about, let me see, using the concrete within the cells and putting concrete specifically on those really steep slopes. So this is definitely a installation type question. How are you going to get the concrete all the way from the crest to the toe when it needs to fill in the GeoWeb cells? And so what you're going to want to do is kind of adjust the slump of the concrete. There's no, we don't have a specific limit. We don't want to say you have to use a 3-inch slump concrete or anything, because it is going to depend on your area in your project as to what kind of slump you need. But basically, you're going to need to have a slightly higher slump, put it up at the crest, and then pull that concrete, rake it into all of the cells, and then make sure it's screeded flush with the top of the GeoWeb panels. So it might need a little bit more handwork than just dumping concrete in and letting it settle itself. But that's essentially what you're going to do. Is you're going to start at the crest, and you're going to pull the concrete down so that it fills all of the cells from crest to toe. Make sure you're screeding to the top. And you do have the ability to adjust that slump in the field as needed to make sure you're doing that. So you can have that slightly higher slump concrete so that it actually flows down to the bottom without worrying that it's all just going to fall straight to the toe. So a couple questions about using concrete over areas that have high water tables, or areas with things like frost heave, where you have to worry about what the soil is going to do underneath the concrete. And always the biggest thing is you're going to need to do something to relieve that pore pressure. You're going to need weep holes. You're going to need a filter fabric. You're going to need something along those lines. How often you need the weep holes is going to depend on what type of water flow you have underneath the system. If you have really high water tables, or if you know that you're going to have a lot of water through the ground slope, you're going to want more weep holes than not. 3-foot spacing is something we've seen. We've also seen wider than that. It is, again, pretty project dependent. I know that's not necessarily the most satisfying answer right now, but it is going to depend so much on what your specific needs are. We can help you determine what that spacing of weep holes might need to be, or whether you need to worry about excavating extra material out underneath the system and putting in an open graded aggregate to try and minimize that frost heave. That's also a solution that we've seen. So obviously the whole point of using the GeoWeb system is that you want to minimize the amount of excavation necessary. You want to minimize the amount of ground disturbance. But if you are in those really sensitive areas, if you are in those areas that are going to have a lot of frost heave movement, a lot of the freeze-thaw cycle, there are mitigation options that you can use with the GeoWeb system, and we're more than happy to talk about those with you. Let's see, I'm going to do one last sort of grouping of questions. These all came in sort of near the beginning when we were talking about the actual GeoWeb material itself. So things like the welds that connect, that actually create the cells, and the sort of strength and resilience of the HDPE. So to start with those welds, we talked about at the beginning, it's an ultrasonically welded seam. So it's actually kind of a cool process, but there is no mechanical stitching. There's no staples holding it together. The actual panels of extruded plastic material are ultrasonically welded together, and that's what holds them in place. So they are connected, and that's where the strength is. So you don't have to worry about some sort of mechanical failure of stitching, of cable ties holding it together, things like that. So that ultrasonically welded seam is part of our proprietary formula of how the GeoWeb system works. So I can't give you all of the details, but it is really important to that function of the GeoCell system. Like I said, you don't want that ultrasonically welded seam to rip apart. That's where the strength of the system is. So as long as things are installed properly according to our recommendations, you're not going to see failure along the seams or along the AtraKey connections. Our recommendations are based specifically on that ultrasonically welded seam, that AtraKey connection, the GeoWeb material itself, to ensure that you're not going to have that type of failure. The only way that you would have that type of failure is if you pretty much ignore our recommendations and overfill the system. So if you're doubling the amount of load that it's holding, yes, it has the potential that those seams could rip, but we really don't see that when it's properly installed. Those are very conservatively designed to be as strong as needed for those really long lifetime projects. And then part of that is because we use that HDPE, that high density polyethylene resin. So it can be exposed to sunlight, it can be exposed to water, it can be exposed to acidic environments, saline environments. You can have chemicals running across it, and the strength and the inert capabilities of the HDPE resin mean that it's not going to have any sort of degradation. It's not going to lose strength. It's not going to degrade, crack, fall apart, create those microplastics, leach chemicals, anything like that. And that is why we chose to use that HDPE, because it is going to be the most environmentally safe and long-term durable material that you can have for this type of project. So I hope that answers some of your questions. I apologize if I didn't get to you today. Feel free to reach out to me directly, but I am going to call it here for today. So thank you everyone again for attending. We really appreciate it. Hope to hear from you soon with questions, with potential projects, or just to say hi. So I hope you all have a wonderful day, and we will see you in the next webinar. Thanks.